Okay, so today we're going to cover lesson 8.4. It's the slope-intercept form of a linear equation. So in this lesson, our objective will be to use the slope-intercept form of the linear equation. So what they're showing right here are the points with these coordinates are all points that are on this linear equation, y equals 2x. And then the other equation, it's got a negative slope, and it's showing here that the slope is negative 1/3 if you were to count the rise and the run. What we're going to see is the number that's in front of x is going to be our slope. Okay, but that's once our equation is solved for y. So the general form of it is down here. And I'm going to go back up and explain what's going on in here. However, y equals mx plus b. Once you have y all by itself on one side of your equation, so notice how here it's isolated all by itself, then as long as the other side of the equal sign has some number in front of x, and then something that's being added or subtracted to the x. This m represents the slope of the line. And remember from last week, slope is rise over run. The b, and this is, I know some people get confused with this, but the b is the y-intercept. Some people think that the y over there at the beginning is the y-intercept, but the b represents your y-intercept, or where your graph is hitting the y-axis. Okay, now we're going to learn how to graph using this method, and we can also think of the b as our beginning. This is where we're going to put our first point when we go to graph them. All right, but first let's go back up here. And notice here, they've got y equals 2x and y equals 2x plus 4. Now, what they're trying to demonstrate here is the number that's in front of x is going to be the slope again. So they both have 2 in front of x. When the slopes are the same, our lines are going to be parallel. So this would be a characteristic that your lines have in common. So on the test, they're going to say, sketch a line or come up with an equation of a line that's parallel to another given one. Just remember that the slopes need to be the same number. So notice here what's different between the red and the blue line is the red does not have a b in this equation. Okay, the b is 0. So that is your y-intercept. However, of this equation, which is the blue line that's graphed, notice the y-intercept, or where it's crossing the y-axis, is here at the point 4. So the number that's being added or subtracted to the x is going to be where it's touching the y-axis. So let's go ahead and try some of these. Go to the next page. So here it wants us to find the slope and the y-intercept. Now notice on this one, they're nice. They put it in the right order for us. It's already set up into y equals m. Let's see, let me fix this. Y equals mx plus b. So again, our slope, remember, is the number in front of x. So our slope of this line is going to be m equals 3 over 5. And again, remember your y-intercept is going to be the number that's being added or subtracted to the slope, or the x term, and that's going to be positive 2. So our b, or our y-intercept, is going to be positive 2. Now, sometimes if you see this on a standardized test, they may just ask you to list it. They may also ask you to list it as a coordinate. So remember, if you were to list the y-intercept as a coordinate, it would be the order pair 0, 2. So when you're listing it in your homework tonight, you could just tell me that b equals 2 or y-intercept equals 2. But just be aware that the y-intercept is an order pair that's on that y-axis. All right, so now here, they want us to graph. So let's go ahead and we're going to practice graphing. I know I erased everything, but I just wanted to be able to walk you through step by step. So again, this is in y equals mx plus b. So the b, so my slope is negative 3/4. My b, which is my y-intercept, or my beginning point, is positive 6. Again, remember, slope is rise over run. So what I'm going to do is I'm going to start at the beginning, which is the b, and on my y-axis, not my x, I'm going to put a point on the positive 6. So 1, let me go ahead and label some little tick marks here. 1, 2, 3, 4, 5, 6. So this is my b, or my beginning point, my y-intercept. And now I'm going to move my rise and my run. Now, notice it's a negative slope. Now, whenever I graph using slope-intercept form, I always like to go to the right. And what I do is I say the top number, I'm always going to go up or down if it's negative. So if it's a positive slope, I'm going up. So positive slope, when I graph, I'm going to go up and right. If it's a negative slope, I'm going to go down and right. Now, technically you could go up and left, but that tends to confuse a lot of students. So this is why I always like to leave one of my movements the same. Okay, so I'm always going to go right, but if it's positive, I go up. If it's a negative slope, I go down. So in this particular problem, starting from my beginning point, I am going to go down 5. So my rise is up and down. That's what that means. So the rise is either up or down, depending on if it's a negative or a positive. And my run is the side to side. Okay, so I'm going to go from my beginning point down 3. So 1, 2, 3. And then I'm going to go to the right 4. 1, 2, 3, 4. So then I'm going to go over here. 1, 2, 3, 4. I'm going to put the red point right here. I'm going to get out some kind of straight edge. If you're using your iPad, just hold down your cursor, connect the 2 points, and you've just graphed your line. Now, you can also graph by finding the intercepts by plugging in the zeros. However, once you get this method down, it's a lot faster. Okay? Now, notice the next example. They weren't very nice to us. They did not give it to us in slope-intercept form. So remember, again, you have to solve for y. So, like I said before, the number in front of x is usually the slope, only when you've solved the equation for y. So if you told me the slope of this equation was 2, that would be incorrect. I need to isolate y first. And the way that I'm going to do that is I'm going to move the 2x to the other side by subtracting it. The 10 and the 2x are not like terms, so they're going to stay separated. Just going to write them side by side. So negative 2x plus 10. And then now I still need to get y all by itself. So I'm going to divide all three terms by -5. So now it's y equals, notice the negative on that 2/5, so it'll become positive. And then 10 divided by -5, I can actually simplify that to -2. Now I can identify my slope and I can identify my y-intercept. Again, y equals mx plus b. Notice this time there's a subtraction sign, so my b this time is actually -2. My slope is the number in front of x, and it became positive 2/5. So now I'm going to graph this using the slope-intercept method. So again, let me make a graph over here. And again, my beginning point is the y-intercept. So on my y-axis, I'm going to start at the point -2. I'm going to put a dot right here at -2 on the y-axis. From that -2, I am going to rise 2. So I'm going to go up 2. And then to the right, 5 for my run. So rise over run. And I'm going to go up because it's positive, and then to the right. So let me add some more markings here. 1, 2, 3, 4, 5. So I can go up 2. 1, 2, and then to the right 5. 1, 2, 3, 4, 5. When you're doing this, you don't need to show these yellow jumps that I'm doing. I'm just showing you how I'm counting them. Then you would put your final point here. So really when you're doing this, all I need to see are the 2 red points and then how you've connected them to graph the line. So when it says graph a line, you should be connecting these points. Now keep in mind, this rise over run pattern, you can keep repeating it. The more times you repeat it, the more precise line you're going to get. So for example, if I wanted to get more points on my line, I could repeat the pattern a little bit more. So let's see if I extended my x-axis here. And let me add 5 more tick marks here. So this is 5, 6, 7, 8, 9, 10. So if I wanted to get another point here, I could also still rise 2 again from the point that I just made. So I could go up 2, 1, 2, and then rise over 5, or run 5 times. 1, 2, 3, 4, 5. I could get another point that's on the line. My line's a little off, but here you would have hit there and that would have been your line. Again, I'm not using a grid. When you're using graph paper, you'll get a nice precise line. So you can keep repeating the slope pattern of rise over run and get more precise of a line. Now, back on that first page, I talked about parallel lines. So notice here in the description, it says that lines in the same plane that do not intersect, so meaning that they don't cross, are parallel. And what you're going to see that's in common between the two equations is they're going to be 2 different lines, but what they're going to have in common is they're going to have the same slope. Okay, so as long as they're not vertical, they're going to be parallel. Okay, so they would run side by side and they would not touch. So let's look at an example. The way that you're going to be asked on the test this week is they're going to say, come up with an equation to the line that's parallel to this, and they're going to give you a specific point. And we're going to practice this. But on this example 4, all they want you to do is show that these two equations are parallel. So what I need to do here is rearrange both of them into y equals mx plus b. And once I do that, I need to check to see if the number in front of x, or the slope, if it is the same number. If it is the same number, then we will say that these lines are parallel. So let's go ahead and rearrange them. 2x plus y equals 8. I'm going to isolate y by subtracting the 2x. So my first equation is now rearranged into slope-intercept, or y equals mx plus b. I need to do the same thing to the other one. And notice once I move the 2x again on this equation, notice that both equations have the same slope. They both have the same number in front of x. Now, when your lines are parallel, they will have different b's. They will have different y-intercepts. So, for example, if I were to quick sketch these graphs, I know it's not in your book, but just to show you, if I do the first one, I'll do this one in blue. If I went ahead and 1, 2, 3, 4, 5, 6, 7, 8. My first point would go on the positive 8. That is my beginning. And then from there, I'm going to move my slope. Again, remember, when my slope, and I didn't show you this, but when the slope is a whole number, this -2, we're going to make it into a fraction, so we have a rise and a run, by putting a 1 in the denominator. So again, it's a negative slope, so I'm going to go down 2 for my rise, and for my run, I'm going to run 1 point to the right. So I'm going to go from this 8, 2 points down, 1, 2, and then 1 point, or 1 to the right. And then I can connect my points, and here's my first graph. I'm going to do the other one in green. My beginning point for this one is going to be +6. So right here. And then from that +6, same rise and run. So I'm going to go down 2 and to the right 1. Notice when I connect the dots, notice how my lines are side by side and they do not cross. So when the slopes are the same, the lines are parallel. They will have different y-intercepts. So your homework for this lesson is going to be 1 through 36 all. So in this section of the homework, 1 through 12, what you need to do is make sure that it is in slope-intercept form. And notice all 12 of these first problems are already solved for y. So again, to find the slope, it's the number in front of x, and the y-intercept is whatever is being added or subtracted. So again, for example, on number 2, my slope here, and you could, when you're writing this as your homework, you could say m equals 3, and you could say b equals -4. So if it's a subtraction problem, your y-intercept is a negative number. Can anybody remember when it's y equals a number? What is the slope of that line? Yes, Brian. 0. Good. And then when it's x equals a number? Undefined. Good. You need to be remembering those. All right. So then now, this part, I know it says to use a graphing calculator or computer. We are not. So on these, you are going to graph them. You need to first rearrange them into y equals mx plus b. Once you do that, then you will graph using the slope-intercept method. Notice the first let's see, up to number 18, they're already in the right form for you. However, once you hit number 19, now you have to rearrange these. So for example, on number 19, x plus y equals 8. I need to get y by itself, so I need to subtract x and get y equals negative x plus 8. Notice here my slope is going to be -1. I assume a -1 in here. And then my beginning point, my b, is the 8. So my m here is -1. Now in this section, 13 through 30, in addition to rearranging it, you're also graphing it. Okay, you could put a couple of them on the same coordinate plane, but I wouldn't put all of them. Okay, so that's what you need to do on these. Let's go ahead. Is 1 through 36 all. So you guys can go ahead. You have a few minutes here. You can get started. And if you need any help on this, let me know. And then tomorrow we will cover 8-5, which again, we're going to be doing more graphing and more equations of the line. See the rest, the last 6. So again, you're going to ask to give equations that are parallel or to show that they're parallel. So in this part of the homework, you're putting them into y equals mx plus b form. And then you're going to look to see if after you put them both in y equals mx plus b, if they have the same slope. Okay? If they do not have the same slope, then you're going to tell me that they're not parallel. Okay? So it's basically you're going to show me the work of rearranging them, and then the answer is yes or no, if they're parallel or not. Any questions? Okay, so again, homework.